Hey everyone, welcome to Data Umbrella's webinar. I'm going to do a brief introduction about Data Umbrella, then Kim will be doing her presentation. And if you have any questions, ask in the chat and we will answer them throughout the webinar. This webinar is being recorded. Data Umbrella is a community for underrepresented persons in data science, and we are a nonprofit organization. This is our team. My name is Reshma Sheikh. Beryl is also online. Beryl is located in Kenya. Christina is in New York as well. I'm in New York. And Sangam is joining us from India. And this is a whole team that makes these events happen behind the scenes. We are dedicated to providing a harassment-free experience for everyone. Thank you for helping to make this a welcoming and friendly community for all. Also, I can't share my camera because I've got internet issues today, unfortunately, even though the weather is clear. There are various ways to support Data Umbrella. The first and foremost is to follow our code of conduct, and please feel free to share our events with other people. There are also other ways to contribute to Data Umbrella. We have our website, video timestamps, Sprint websites on GitHub. Feel free to check them out. Our nonprofit, we are on Open Collective temporary. We'll be moving, but we are on there for donations if you'd like to support us that way. And subscribe to our Data Umbrella YouTube. We now have over 100 videos on various topics in data science, Python, R, and open source. We have playlists such as career advice and data visualization, contributing to various open source libraries, scikit-learn Sprint series, and NumPy, just to name a few of the playlists. We also have a monthly newsletter. I'm going to share the link in the chat in a minute. We send out a newsletter on the first of the month so you can get some updates on what's happening in the data science community, as well as our upcoming events. This is a QR scanner for our most popular events. Meetup is the place to go to find out about upcoming events, and YouTube is the place to go to find out about recent events. This webinar platform that we're using is called Big Marker, and on the top right you may see two small letters called CC for closed captioning. So if you'd like a live transcript, you can follow along that way. We also have an online suggestion box. If you have suggestions for future event topics, let us know. If you have any feedback on this event, if you want to share any technical issues that hopefully you have not experienced, but if you do, let us know. And if you have any other feedback, and if you're interested in speaking at Data Umbrella, let us know. Our next event is on October 22nd, which is 2 weeks from today, and it's called Ragged Edge Box, and it's a personal AI-powered document search system, and that is posted in our Meetup page. Today's talk is Polars for Data Analysis in Python. Our speaker is Dr. Kimberly Fessel, who is a data scientist and founder of Dr. Kim Data. She and her company specialize in technical instruction, machine learning, and data visualization. Kimberly has over a decade of experience educating groups and individuals in corporate settings at academic universities via online platforms and as director of a data science bootcamp. Her educational YouTube channel features videos about data science in Python and boasts over 20,000 subscribers. And I will add, you hit 1 million views as well, which I saw posted on LinkedIn. Congratulations. Kim holds a PhD in applied mathematics from Rensselaer Polytechnic Institute and expects the publication of her first book, Head First SQL, in 2026. And you can find Kimberly Fessel on LinkedIn. Okay, and with that, I am going to hand over the microphone and the screen share over to Kim.
Thank you so much for the introduction. I am beyond pleased to be here with you all today. I recognize a couple of you in the chat, and that's just so wonderful to kind of see the data fam, as one of you all called it, kind of grow and get used to people, and that's just so wonderful. So let me go ahead and start. We're going to start with a couple slides, and then we're going to dive into a demo about polars. Hopefully everybody can see the sides. Just let me know if you can't. So today we're going to be talking about polars, and there's lots and lots of things you can do with polars. What I'm typically interested in doing with polars are things like data analysis. So I'm a data scientist. In my kind of experience, the clients I work with and these sort of things, I often need to do data handling, and Polars is a new library that I am gravitating toward because it's really, really cool, and I'm excited to share it with you today. Okay. I am Kimberly Fessel, as Rachel was talking about and giving me a great introduction already. But just to let you know a little bit more about myself, like I said, I've been a data scientist for about 10 years now. I've certainly seen the field change in those 10 years, and I'm sure it's going to continue to change in the next 10. But I'm also a data science educator. I have been in academia in the past. I've taught students at colleges. I've taught students online, in person, et cetera, et cetera. So that's one thing I absolutely love to do is share knowledge and to instruct. Going along with that, I am the ex-director of a data science bootcamp. So in that experience, I worked with lots and lots of students to skill them up into data science roles. And from that experience, now I have founded my own company called Dr. Kim Data, where I'm doing technical trainings for clients as well as some data science as well. So let's start with the materials. And I think probably you have some idea how to answer this question already, but let's definitely set a baseline so we all know what we're talking about. What is Polars? Polars is, quite simply, a high-performance data frame library. So you may have experience with data frames in the past with other libraries. And I would say those experiences, just thinking about data in a tabular sort of way, will definitely help you if you choose to explore Polars as well. So we're going to be talking about kind of how Polars thinks about data, what's the ideas behind it. But this is the main thing to keep in mind. We want to deal with data in a tabular way in a data frame. And we're going to do that with smart techniques to have high performance. Now, high performance in terms of speed, of how fast our calculations go, but also how much memory we take up and how all those calculations are processed. We're trying to do that in a really, really smart, clever way so that we can have great efficiency when we're working with data. So the main objective of Polars is efficient data handling and analysis. So you can clean your data, you can perform aggregations on it, you can filter it, all those nice things that you're probably already used to with some other library, you can do here in Polars as well. But one of the key hallmarks of Polars that is so different from other libraries is that it's actually built in a language called Rust. Now, you may not know about Rust, you may not be able to code in Rust, that's totally fine, you don't have to. But the core part of Polars is actually written in Rust, which is a very fast programming language. Now, on top of that core functionality in Rust, we have a Python API. So that's what we're going to be doing today, all about Python, all about interacting with that Python API. But just know that kind of one of the reasons that Polars is so fast is it's not actually doing everything in Python, it's doing things in Rust. And also, if you do already know Rust, there's a Rust API too. You can just write Rust code, that's totally fine. But if you are a Pythonista like myself, you can use Python. The other really great thing about Polars is that it is an open source language. So it's free to download. There's a GitHub. You can see everything that's going on inside of it. You can modify it and so on. So I just think that's really, really nice when you're learning a new package. If there's some part of it you're not exactly 100% sure how it's working, you can actually just go look at the code if you'd like. As far as development and adoption, I think, if you're here at this talk, you're probably already excited about Polars, but just to give you a sense of kind of, when it came on the scene and how popular it is, Polars was introduced in 2020 by Richie Vink. And it's interesting, the story of Polars is kind of like Richie Vink developed this during the pandemic. And so that's not what I did with my time. I didn't develop this really, really cool library, but some people were very productive during that pandemic. And I would say this Richie Vink was. All right. And we also have over 65 million downloads of Polars already. So the library has only been around for about 4 years, and we've already got 65 million downloads. So it's certainly a popular library that's gaining traction every day. All right, so what are some of the key features? Why is it so cool? Why are we talking about it? Well, speed. I think that's probably the number one thing that when people consider moving toward polars from some other languages, some other packages and so on, speed is probably the first thing that comes to mind about why you might want to make the switch. It can be up to 30 times faster than Pandas. Okay, so that's probably where I would say that most people kind of, if you're in Python, you're doing data handling, you're probably using Pandas. So if you want a huge speed up of your calculations, if what you're doing is just taking way too long, polars might be the library for you. In some cases, we can speed up to 30 times faster. And it's not just Pandas. I'll show you a visual that's actually on the polars webpage. These are benchmarked results from TPC. It's the TPCH benchmarks results. So this is basically a set of SQL queries that you can run against your machine to see how fast, how fast your machine goes, how fast your language goes. So those SQL queries have been converted into these various different languages. And as you can see here, you can see the circle. Some languages like Modin there did not even finish. But we have Pandas, which took 207 seconds to run these particular queries against this data set. Dask is a lot faster, so you might have some experience with Dask. It's the first kind of alternate that people go to for fast Pandas, might be Dask. That only took 67 seconds, which is certainly an improvement. PySpark, which is another one that people like a lot, 55 seconds. But take a look at polars. It took 8 seconds to do these benchmarks, did the first few benchmarks that they tested it against, right? So that just kind of gives you a sense of how much you might be able to speed up, certain tasks. Okay. All right. So speed's the first key feature of polars. And how we're able to achieve a lot of this speed is through parallel computing, right? And also memory efficiency. So not only are we going to be faster, but we're able to conserve memory as we're doing it. Okay. So the main thing that, one of the main things that polars has going for it here is that it's able to do automatic multi-threading for your computer. So, threading is possible in Pandas. You can say like, okay, I want to use, separate cores for this, that, and the other. But with polars, you don't even need to change your code at all. It's going to automatically do that for you and be able to run calculations across your machine. We're also doing a lot of vectorized operations. This is nothing new. Obviously, Pandas does this as well, but just keeping that in mind, like we're using vectorized operations to speed everything up. And a lot of the aggregations that you'll see us do here can be done in parallel. So yet another way to just speed everything up, being able to work on multiple things at once is something that polars is fantastic at. We also use arrow memory format, and now you can do this in Pandas as well, but you have to kind of set some defaults, change some defaults. This is the default for polars. It's just going to use arrow for the memory component there. Okay. All right. So besides all that really awesome stuff, which is already great, you have the option to do lazy evaluation. And so I love this slide because I'm a huge fan of sloths. And so if you're not familiar with what lazy evaluation is, this is not a new concept. There are other packages and things that will do lazy evaluation. So let me just tell you what that is. Lazy evaluation is a computational strategy where expressions are not actually evaluated until their values are needed. Okay, so I might be able to write some code like, hey, filter this data frame and then aggregate this and that and the other, but we don't actually get results until we pass in a particular piece of code. In the case of polars, we'll say collect, but we'll basically say, okay, now I actually need those results. Go ahead and compute everything. And you may be thinking, how is that useful? You're just storing up all these code bits. It doesn't really make any sense. Well, it is very, very useful for the computer because you're not actually compiling everything together. You're not actually getting those results. Your computer is able to create an optimized execution plan. Okay, so polars is able to say, okay, which is better, filtering by this particular column or only selecting a certain number of columns first? So all the different things you're asking for within your code, it can decide which of those is going to be most efficient to do first and then build up a plan. And so if you're saving those operations that you need, and then passing them all at once before you actually need to pull the values back. And you're able to actually say, okay, which thing would make this entire computation run faster? Which steps should go first in which order? All right, so that's pretty cool. And it definitely, helps with, again, the speed aspect when you're working with really, really large data sets, helps with the memory aspect as well. Okay, and it reduces your resource storage usage, right? So you're not actually doing, calculations in succession. You're able to kind of compile all those calculations together, decide what order can we do things in, can we do some of this in parallel or so on, and then able to come up with a plan. So that's lazy evaluation in general, and polars, you can do that. I'm actually going to show you both with lazy evaluation and without it. So you'll be able to see that polars could do either, just depending on what you need. All right, so I'm going to pause here. Have there been any questions, or does anybody have anything they'd like to ask at this point?
There is one question, which is, I thought, then this is from one of the earlier slides you presented, I thought Modin brought more speed up. Was this run on x64 architecture?
Yeah, I'm not actually sure. Yeah, definitely check out that study because you're right. Yeah, it should be doing okay. So it has the DNF. I did look into this a little bit. It was actually, I think, a set of 7 different queries they tried to put together, and I think only one of them didn't finish. So definitely look into it a little bit more. What exactly happened, but I do think there was just one calculation that didn't quite finish, so then they declared the whole thing DNF. But yeah, definitely look into it's on the Polars website. I think it's right on the home page. You can kind of see, and then it links to the blog where they talk about the tests that they ran.
And one more question is, how is it able to achieve multi-threading since Python has an interpreter lock?
Yeah, this is kind of almost beyond my, I'm not a computer scientist. What I would guess is that we are actually running things in Rust. So take a look at that, check everything out. But again, remember the Python API is just, the icing on top of the cake. And then the actual part, the Polars like core language is Rust. So yeah, that's me guessing though. So yeah.
And that's it. No more questions.
Okay. All right. Great. We'll have more question slides coming up. So yeah. All right. So let's take a look a little bit more. Probably one thing you kind of came into this talk probably is like, hey, can I compare polars against other languages and other packages, right? So how does polars compare to other things? Let me just give you a sneak peek at some of the syntax here. This is just one line of code. And basically what this would do, we would start with some kind of data frame or a lazy frame, as they call them. We would be grouping by a particular column, aggregate some other column for each group. We're summing up column 2 for each group. And then this final collect would be necessary if we're using lazy evaluation. Go ahead and evaluate all of the results. Okay, so when you start to look at this code, to me, it reminds me of 2 other packages. It reminds me of Pandas for sure, like group by and those kind of things, and this, chaining of the different methods. But it also reminds me a little bit of PySpark, if you have familiarity with that, especially the idea of collecting the results at the end and these lazy evaluation, lazy operations. So it's kind of like a cross between Pandas and PySpark. I would also even maybe say a dash of SQL mixed in. As you'll see later, window, over and those kind of things. Window functions uses a little bit more like SQL syntax. So if you know these other languages and packages, it's only going to help you when you're trying to learn polars. It kind of looks like a cross between some of those other things. Okay. So specifically comparing against Pandas, I would say there's a lot of similarities. First of all, they're both for data handling and analysis. The data frame and series objects are the same, right? So polars uses data frames, which are more like tables of data, and series, which are more like columns of data. And that's exactly the same as Pandas. We have many of the same types of operations. So group by, aggregate, these sort of things, very, very similar types of operations it can do, and even sometimes similar names for the syntax, which is great. And like I said, familiar syntax, it's going to probably feel at least familiar. There are differences. They're definitely not the same language at all, or not the same package. I keep saying language, sorry. Not the same package at all, but it's going to feel familiar, I think. All right, but there are also some differences. One thing you'll see when we start, playing around with polars here in just a minute, is that we don't have any index names for the rows. Okay, so that's one thing that some people really do like about pandas and some people really don't like about pandas. But we aren't going to have any row names in polars. There's a lot more parallelism baked into what polars can do, and that's kind of happening behind the scenes, but ultimately that means your calculations can run faster. The optional lazy evaluation, which is possible with polars, yeah, that's something that's a little bit different. If you're not used to that lazy evaluation, it may take a little time to just kind of understand and get used to that, but it is optional. You don't have to use it in polars. It can just potentially help speed up everything later. And some people think that, polars has better syntax. So some people say, I came for the speed, but stayed for the syntax. That's kind of like the, joking kind of quote that goes around. You can certainly decide for yourself. Some people don't enjoy that Pandas has multiple ways to do things. And I would say that polars is a lot more streamlined, and there's pretty much one way to do things. There's sometimes a little bit of overlap, but mostly there's one way to do things. So I do think that's maybe an improvement over Pandas, which has a lot of different ways to do the same thing. If you have explored ways to speed up your pandas, you may have come across Dask and tried to use that. And so comparing Dask against polars, so Dask is more for like the outer core processing. So it can help speed everything up, of course. It does have parallelism and lazy evaluation. You can do that in Dask. But remember, Dask is still a Python language, whereas polars is Rust at its core. Like a rusty core. That doesn't sound good, but it actually is really good. Okay. One thing about Dask, if you've used this, potentially you have started looking into cluster computing. With Dask, you can farm out your calculations to multiple computers. Polars is mostly written with the idea in mind that you're going to be using a single machine. I believe it's possible to do a little bit more fancy stuff, but polars is honestly mostly for high performance computing on a single machine. Dask also completely uses Pandas syntax. It's pretty much just Pandas, whereas polars does have its own unique syntax. So that's a bit of a difference as well. Another package or language now, or totally different way to do things that you might be comparing this to is Apache Spark. Excuse me. Apache Spark is performant for big data. So now it's really for really large data sets. That's when people typically go towards Spark. It definitely has the parallelism. It has the lazy evaluation, just like polars does. But Apache Spark is more now written in Java and Scala, whereas, again, polars is in Rust. So differences in the language there. Apache Spark is absolutely for cluster computing. So that's one way that you may have used it in the past, is being able to use multiple machines, for one calculation. Again, polars is mostly for the single machine. And one thing I will say here, if you are dealing with a really, really large data set, you're probably still going to go to Apache Spark as opposed to polars. So I'll talk about that at the very end of the talk. When would you consider using polars or not? If you have just a gigantic, terabytes of data, et cetera, whatever, you're probably going towards Spark and not going toward polars. All right. Any more questions about that, about comparing polars to other things?
No questions so far.
All right, great. Oh, so I'll just keep going through, because next we actually get to the coding part, which I think is the fun part here. Okay, so getting started with polars. What will we do to get started with that? Well, installing polars is a lot like other, so again, polars for Python. So if you're going to be using this in Python, you can use pip install. You can do pip install polars. Absolutely, that works. But if you'd like to have additional plotting capabilities, you could use this polars plot. That'll just install whatever plotting capabilities polars currently comes with. We're going to go through two different notebooks in this presentation here. The first one I'm going to start with is called Getting Started with Polars in Python. And I think Rishma already shared a link, but you can find the GitHub repo with all of these materials at bit.ly/du polars, and that is case sensitive. So if you're going to try to follow along, make sure that you've got capital D, capital U, and a capital P in that web address. All right, so I'm going to go ahead and switch over to that notebook. Okay, hopefully we see my notebook now. Looks like we do. Okay. So let's take a look at some polars code and just start working with some of this data. Again, so once you have polars installed, you will need to import that library. So the common alias for polars is PL, and that's what I'll use here as well. So import polars as PL. So let's go ahead and create and read in some data and just see what that looks like in polars. I'm using a Jupyter notebook here with drop downs. So if everything looks like there's no content, I'm just going to be expanding that to show you the code as we go through. Okay. All right, so let's say that we want to create a data frame. Remember, that's the core object of polars. We can create a data frame in polars by just doing pl.dataframe. And there are multiple ways to do this, but I think one of the simplest is just to pass a dictionary directly into that data frame function. So student will be my first column. I will have grade, score, and subject as well. All right. We're going to save that in DF, which is a polars data frame. Pardon me for just a moment here, trying to, let's try this, see if it's working. It's not working. Okay, let me restart this real quick. Okay. All right, sorry about that. There we go. Okay. So I was trying to just show you what DF would look like. So here we go. This is what our polars data frame would look like. When you kind of print out, or this is Jupyter Notebook, so we're just kind of executing that data frame, you'll see the shape is one of the first things that polars will show you. So that automatically shows up when you're looking at these data frames with 3 rows and 4 columns. You'll also notice that we don't have any index labels here. So that's different from Pandas. But we do have the column labels. That's still, each column is going to be labeled with a name. And we also have the data type of each column. So that automatically shows up whenever we look at our polars data frames. Okay, so we have strings, we have integers, floats, and more strings. Okay, you'll also see that you have quote marks around all of your strings. That kind of helps you understand, okay, that's a string, like pretty quickly, whereas opposed, the integers and the floats do not. All right, but if you don't want to create all of your data all the time, obviously, what we're probably more likely going to be doing is just loading in data from CSVs or Excel Excel files or so on. So you can do that with Polar's read_CSV. Sounds just like Pandas there. I'm going to actually be pulling this information in from a URL, but you could, of course, reference a local file on your machine. And here's what that file looks like. I'm calling this one serial because it has about 77 rows with different serials and their facts. Okay. Any questions about just kind of loading in data or anything like that?
So there are a couple of questions. Can you clarify what size data sets are for polars? 10 gigabytes, 100 gigabytes? Also, can polars be multi-threaded for file I/O input output or just for processing a single file at a time?
Right. So as far as how big of the files, certainly gigabyte, a couple gigabytes is no problem. I actually was working with one, and honestly, what it's going to come down to is also your machine. You know, how much RAM do you have? How much, et cetera. So I would say probably it's going to come down to that. But yeah, we're talking about, certainly a few gigabytes. I was trying to do a file that was 10 gigabytes yesterday and was getting a little bit of issues. It was getting a little finicky with me. But again, my computer is like, I don't know, 6 years old. It's pretty bad. So you may have more luck there. But I would say that's kind of the range that we're talking about, tens of gigabytes, as opposed to like terabytes. Yeah.
And another question is, in Pandas, the fundamental building blocks are series, parentheses, columns, and data frames, which are tables. Those polars have the concept of series independent of data frames.
Yeah, it does. It does also have series as well. Yes. So columns of data would also be series here as well. Yes, same.
And one last question. I'm a bit confused by the multiprocessing page on the polars documentation. It seems to have you import multiprocessing and use a specific method, quote, spawn, to perform jobs. Is this not necessary since you said it has multiprocessing built in? Also, if it's built in, does that mean there's no way to control its multi-threading behavior?
So this is one where I'm not 100% sure here. Again, this is kind of reaching the limits of my, knowledge at this point. I would just keep looking into it. I think the documentation is just pretty good, but yeah, like there are definitely some intricacies there to understand. I have a feeling that you can control it, but I don't know for sure. I'm sorry about that. I don't know for sure.
And that's it.
Okay, good. All right. Okay, let's keep moving on then. Okay, this notebook is just kind of to show you a few of the things that you can do. Certainly go back to it if you want to, memorize the syntax or so on. But a lot of these things, again, look very similar to Pandas. For example, you can do serial.head, and you'll just see the first 5 rows of that data frame. You can also do sampling, just like you can with Pandas. The syntax here is slightly different. If I want to sample 10 rows from that data frame, I can pass in the number 10. The argument is called seed instead of random, I believe it's random state in Pandas. But yeah, it's the same sort of idea that we'll all get the same 10 sampled rows if we pass in a seed here for the random sampling. So you can select, a subset of the rows. You can also select a subset of the columns. So if you'd like to, this is one first big deviation, I would say, from Pandas. When you are selecting rows in Pandas, we all those square brackets that we see all over the place with Pandas. In this case, we actually use a method called select. And not only are we going to use select, we also need to reference the column with this pl.column and then the column name. So anytime we're referencing the columns, we actually need to use, typically we're going to need to use this pl.column to let polars know that we are talking about a column from that data frame. All right, so there's just the fiber column. And if you want to pull out multiple columns, you can pass those in a comma separated. It's not even a list. You can pass those comma separated into pl.columns. There's the name and the fiber amount. So that's one pretty big difference in how you would select specific columns. You're going to use the method select. Okay. For filtering data, this is also a little bit different compared to Pandas, say. So we aren't going to be using masks or things like that. We're actually going to use a method called filter. Okay, so here's just some a set of a sample from that serial data frame. And if we take a look at this MFR, that's the manufacturer column. So these are just short codes for who makes the cereal. By the way, this cereal data set is from about 1990 or so. So it was a while ago. So some of these have certainly been discontinued and some of them have switched manufacturers at this point. But you can see some of these G for General Mills, K for Kellogg's, and so on. Okay, so if we wanted to know all of the cereals that were made by Kellogg's, we could go down here to the serial data frame, do dot filter, and we are referencing the manufacturer column. And again, anytime we're talking about a specific column, we need to use this pl.call. Okay, so that just lets pollers know we're talking about a column name as opposed to some string. So anytime that column, that manufacturer column is exactly equal to K, I'd like you to go ahead and give me that row. And so in the output, we see all of the Kellogg's cereals. So that's a little bit different, again, compared to the masking that you'll see in Pandas. You just use dot filter. I believe that is similar to PySpark instead. All right. But if you have multiple different filters you'd like to apply, you can absolutely do that. The ampersand can join up multiple different conditions, or you could use the pipe for the logical or. So this is saying I want Kellogg's cereals, the manufacturer is K, and the sugars have to be greater than or equal to 10. So there's the sugars. These are all the good ones, right? Apple Jacks, Corn Pops, Fruit Loops, a lot of sugar in those. All right. Another thing that we do a lot whenever we're talking about data analysis is add new columns. So we'll rearrange kind of what we have. We will divide by columns or divide by numbers or so on. So you can do that in pollers as well. Now we're going to be using a method called with columns. Okay, so here's the bottom part of this serial data frame. I just wanted to show you yet another method you can use, tail. That's another one in Pandas you can use, and you can also use in pollers. So here's the bottom part of that data frame. We have the calories listed here, but we also have the cups over here. And so what this means is that all of these different metrics we're looking at for these cereals are actually how many calories or protein or so on per serving. Each serving can be different depending on what the manufacturer has specified as a serving. So for example, 3/4 of a cup is a serving for this cereal, whereas a whole cup is a serving for this other cereal. So we could say, hey, let's create another column where I've taken the calories and divided that by cups. So I can say exactly how many calories per cup. So let's try that. I'm using with columns, and this with columns is actually going to keep all of the previous columns as well as trying to create any other new columns that I specify within the parentheses, okay? But if we take a look all the way over on the side of this data frame, it doesn't look like that calories per cups column has been created, okay? What's happening here, this is one of the first really interesting and maybe almost a little bit weird things about pollers for me when I first started looking into this. If you don't specify an alias for that new column, pollers will overwrite one of your other columns. So if we actually look over here at the calories column has just been overwritten with calories per cups, okay, instead of the original data. So if you would not like to do that, if you would like to create an additional column as opposed to overriding one of your columns, you can go down here and just add .alias and give that column a new name. Now when we run that, we will see an additional calories per cup column over on the right-hand side, the final column. All right, so that's one huge thing to watch out for. Don't forget to alias the columns you create. If you don't alias them, you're just going to overwrite your current columns. Now, sometimes you do want to overwrite your current columns. So, sometimes that is the behavior you'd like. But if you'd like to have new information in a separate column, you need to alias it. The other cool thing about Polars, remember that it's trying to do everything in parallel. It calls itself embarrassingly parallel. So if I'm trying to create multiple different columns at the same time, I can actually do that, in parallel, right? So I could create a bunch of different columns, and all these calculations could be happening at the same time. So here I'm creating that calories per cup column. I'm also creating another Boolean column here to say, is the sugar amount more than 10 grams or not? And I'm going to call that high sugar. So it's doing both, creating both of those columns at the same time in parallel. So if you are trying to add lots and lots of columns, you can kind of put them all within the same with columns command so that you're doing things in parallel. And if we look all the way over on the right-hand side, yeah, now we have the calories per cup column we're just creating, and as well as a new Boolean column to flag high sugar cereals. Okay. And one thing to keep in mind, just like with Pandas, you're not actually changing the underlying data frame as you're doing these operations. So I haven't actually saved that either of those columns I was just creating to the actual data frame, the Polars data frame, unless I override it. So just keep that in mind, like the operations you're doing don't actually save, right, until you do that. All right, any questions here?
No questions so far.
Okay. Okay. I want to make sure that I'm able to show you the advanced. So again, apologize. I think I had a lot more material here than an hour will fill, which is always a good thing, right? So let me make sure to show you some of the advanced things that you can do. There is additional information here. Feel free to take a look outside of this. I've got different things about how you can treat missing values and how you can join data frames up. So you basically are using a join method here. So Polars can do inner, outer, left, right, cross joins, all the sort of things as well. So you can join up all those data frames. You can also eventually, as you are ready to save some information that you've created. So I actually haven't created this new data frame yet, but if you were to create a new data frame and you'd like to write that to a CSV, it's really just called write CSV, and then you can save your data frame in a CSV file. It's pretty simple. All right, so let's go ahead over to the other notebook, because I just wanted to show you a little bit about the lazy evaluation. So this is the second notebook called Advanced Data Analysis with Polars. And once again, I'm just going to import the Polars library, and I'm going to load some data. The difference about this notebook versus the other one is I'm actually going to use that lazy evaluation in this one. So the main thing that you have to change if you want to use the lazy evaluation is, instead of using read CSV, you'll use scan CSV. So this is some data. It's actually included in the GitHub repo if you'd like to try this out for yourself later. But it's about some flights, some flight information. So I've actually used scan CSV instead of read CSV, and it looks like that operation was really, really fast, but I haven't actually read in all the information yet, because now I have what's called a lazy frame instead of a data frame. So this is a way that if we are working with really, really large files, I would definitely recommend using the lazy evaluation instead of a regular read CSV, which is an eager evaluations. So we haven't actually loaded all of that data into memory. We've basically just kind of looked through the file a little bit, just enough so we know kind of what the headers are and what data types we have. That's about all that Polars has done at this point. We haven't actually loaded all that information into our memory. Okay. If you run your regular methods that you're used to whenever you're working with these lazy frames, you won't actually get results until you really ask for them. And so what I mean by that is, here's our regular dot head that we normally do for, for the data frames within polars. But instead of getting information back, I get this explanation of what polars plans to do whenever it actually needs to do it, right? So a lot of your methods will give you a plan of what polars plans to do rather than the actual information as you're doing it, okay? When you are ready to actually get your data, when you say, okay, now I really need the data, go ahead and execute all of these operations, you can do .collect, and that will actually go ahead and pull the data it needs into your memory. But it actually hasn't. So in this case, I'll show you in just a bit, the file is, millions of rows long. It hasn't pulled all of that into memory. It doesn't need all of that. It only really needs the first 5 rows. So that's what I've got. So it allows polars to be a lot more efficient rather than one operation after the next. You can kind of combine operations, and then eventually when you actually need all that information, you can use .collect and you'll get your results. Okay, so just for example, here I'm selecting the length of the data frame, and I'm saying I do actually need that information. You have almost 6 million rows in this file. And even that was pretty fast, just to be able to count how many rows there were. That was pretty fast for polars as well. All right. Here's just a couple more examples, and I'll switch back over to the slides to tell you a little bit more about some other things that polars can do. But here's what your code could potentially look like as you are working with polars. You would maybe start with a lazy frame. You would select a couple of columns. This is here, let me go back up and show you. This is kind of about flights that happened in the US. And so we have the year that the flight took place, the month, the day of the week, etc., which airline operated that flight. And we also have things like the origin airport, the destination airport, when the flight was supposed to take off, and if we had a delay for the departure, if we had a delay for the arrival as well. So there's lots of really interesting information in this data set, but maybe we don't need all of it for the particular analysis that we're doing, right? So if I just need to know which airline which airline I'm talking about, and then I'm trying to average their arrival delays. If I just want to know which airline kind of gets people in later than other ones, which one has the biggest delay. So I might just need those 2 columns. So I'm just selecting those 2 columns. I'm also filtering by, if you notice, some of those delays have negative numbers. That means that the plane was actually early. So if I just want to look at flights that actually had a delay, I might filter by that arrival delay being bigger than 0. I could group by airline. I could take the average for all the flights that actually had delays. And I could sort this by the airlines with the largest delays first, and so on. So your code might look something like this, where you're just applying lots and lots of different methods to your lazy frame. However, we haven't actually done anything yet. Until we do that .collect, polars is just coming up with a plan of how it's going to execute these things, right? And you can even look at this a little more carefully if you'd like to do this explained and optimized and so on. But when we actually add the collect, we'll actually execute the code. And so what I mean, and that was so fast, right? It had 6 million rows and was already super duper fast. But what I mean by it's coming up with a plan, the way I wrote this may not be the best way to do things. Should we go down to just those 2 columns first, or should we go down to only the rows that had, a delay or not? So, we're letting polars kind of decide which way is the best to execute all of these different operations that you need. And so it's able to execute all those operations in a way that makes the most sense for the type of data you have. If you had a different data set, it might make sense to do things in a different order. You don't have to come up with all of that. Polars is going to decide that for you, which is pretty great. All right, and here's our results. We have our, the airline with the largest delay at first, and then the lowest delay at the bottom. Any questions about that one?
We have a couple of questions. The first is there a polars equivalent to pandas, quote, in_place equals true, closing quote, flag, to make the transformation overwrite the current data frame?
Oh, in place. I haven't found one yet. I have not found that yet in polars. I have not seen that yet. However, overriding the variable where you would say like, LF equals all this other stuff, like overriding the variable, that works. But I don't think they have an in place argument. Not that I've found yet. No.
Okay, and one more question. What are the options for plotting data in various graphs in polars?
Mm-hmm. Why don't we do that section? Yeah, we'll do a cursory part of that section as well. Yeah, sure. We'll do that in just a sec.
And that's it.
Okay, good. Okay, good. Yeah, I apologize. I have quite a bit of material in here for you. If you'd like to take a closer look at this, feel free. It's on the GitHub. For example, there's lots and lots of different, string concatenation and Windows functions, and you can even do your own user-defined functions if Polars doesn't have it yet. Because again, Polars is only about 4 years old, so if they don't have a function that you need yet, you could create your own function and then just apply it, through Polars. Okay, so that's possible as well. You can process SQL queries with Polars. There's a section in here about that. I'm actually going to run these because we're going to need some of this information for the plotting. So, here's a huge SQL query that we can execute via Polars, right? We just have to register our data frames. And this walks you through how to do that. But let's show the plotting since we had a question there. So here is how you can natively plot with Polars. It does have a plotting option as long as when you're installing it, you say, okay, I'd also like the plot and do those square brackets with that. Excuse me. So this is another data frame that I pull in, some more information, but it's showing you all the different airports that are in this data set. And I'm plotting the latitude and longitude, and then I'm able to do a tooltip, which will tell us which airport we're looking at. There's Indianapolis and so on. So this is like you use the data frame, you say, hey, I'd like to plot. The point tells Polars that you want to scatter plot, basically. And so this syntax is going to be reminiscent of alter, and that is the current plotting package that is underlying of Polars. It used to use hvplot, and now it is using alter. So if you already have experience with alter, that's what Polars is going to use as well. However, if you'd like to use some other package for plotting, for example, this is just telling you if you have a lazy frame, you have to collect that information first. So let's do that. Excuse me. This is some histogram that you can build out of your lazy frame. If you want to use something other than alter, you can use matplotlib, seaborn, plotly, hvplot, all of those except Polars data frames in series. Okay? So for example, if I have seaborn, I have my airports data frame. So this is still, airports data frame is still a Polars data frame. I can pass that directly into seaborn. There we go. And I'm able to do any kind of plotting I know how to do with seaborn, I can do with a Polars data frame object. And if all else fails, I should definitely tell you this secret as well. If all else fails, you can actually just convert your Polars information into Pandas information, right? So if I load in Pandas and I convert my airports DF was a Polars data frame, I can just say to Pandas, and now I've got a Pandas data frame, and I can do all of the things that I know how to do with Pandas. I could do that now. So yeah, so if all else fails, you can just convert over to Pandas. That's another option. All right, I'm going to switch back over to my slides. If anybody has any questions at this point, feel free to ask.
No questions so far.
Okay. So I'll just switch back over to the slides for the final couple minutes here, and I'll stick around for more questions if there's anything else. But yeah, here was the big question. I think people kind of came to this talk hoping they could answer this. Should you switch to polars? There's a lot more that you can do with polars that I wasn't able to show you today, like so much more. So for example, if you've got other data sources, it doesn't have to be a CSV. It can read in Excel or Parquet or JSON or from a database. It can do all of those things. So if that's what's limiting you from switching to polars, don't let that be a limiting factor. It can read all of those. You can work with really large files with polars. I already talked to you a lot about the lazy evaluation, but there's also something you can do with streaming. And so this is, I think, maybe some questions we had before would be answered by this. So if you have information that's larger than RAM, so my 10 million row file that I'm going to have to do something with, this is probably what I'm going to do with it, is use streaming. If you have too much information to fit into your RAM of your computer, then you can pass file paths and utilize a streaming option to perform the same sort of calculations across files that are broken up into different file paths, if that makes sense, right? So you can do things where if you have more information than will fit into your RAM, you could stream the same sort of calculations on multiple files. And that's probably what I'm going to be doing for my situation. There's so many other things. You can pivot, you can do two dummies, all that sort of stuff if you're used to those things. All kinds of different expressions you can do. Tons of string manipulation, tons of time series stuff, set operations if you're interested in those, and even styling the results, like doing conditional formatting for the way that you're looking at the tables. You can do those things too. So when should you use polars, and should you use polars? I would definitely say anytime you've got a large data set that you need to work with on a single machine. So if you just have your personal laptop and you've got really large files, polars is a great way to go. Cases where it may not make so much sense, if you have a small scale exploratory analysis where you're just typing in some, you don't have that big of a file and you're just trying to see a few different aggregations on your small data frame or whatever, it may not make sense because you're not really waiting for those calculations to run. What you're waiting for is your brain to figure out what's the next step, right? So if speed is not prohibiting your analysis, then maybe Pandas is totally fine, right? If that's what you're already comfortable with, you could stick to it. Obviously, if you want to do polars, you can, but wouldn't necessarily need to in that case. Also, if you have really large cluster computing, polars is probably not your thing. You probably want to go more towards Spark if you have terabytes of data across multiple different computers. So in conclusion, as far as next steps, if you're a Pandas user and you feel like this is you, that you just want to jump over to Polars Express. Oh, Polars Express, nice. Okay, anyway, so if you feel like you want to head off to the exit for Polars, try Polars out on your own data. That's definitely how you really get, really learn what's going on. Try it on your own data. Try converting some of your Pandas code into polars. That would be a nice exercise to make sure you know how to do everything you know how to do in Pandas, you could do in polars. Try determining the best platform for your particular case. Again, if you have gigantic, terabytes of data, it's probably not polars, or multiple different computers, probably not polars, and so on. Just try to decide, does it make sense to even be using this platform? And check out the homepage. I found a lot of great information there as I've been learning about polars. I think the homepage is really great. It has a lot of great information there. Also, I would say, check out the GitHub that I shared with y'all because there was a lot more calculations and a lot more code that I wasn't able to get to in the talk today. There's the polars homepage, pola.rs. There's a getting started section that kind of walks you through the code you'd need to really get started with polars. There's also an API Python section. So if you're a Python user and that's how you want to use polars, this can give you all the great documentation about exactly how methods work and so on. There's tons of stuff on YouTube. So this data umbrella talk will be there eventually. I'm planning to have a polar series on my channel. I'm sure there's lots and lots of other great resources as well. And thank you so much. I would love to stay in touch. If anybody would like to do that, I'm on LinkedIn, I'm on YouTube and GitHub, and I have my website for my company. So thank you so much. Thank you.
Kim, thank you so much for this amazing presentation. Do have a few questions here. You may have answered us, but let us know.
I didn't hear a question. If there was a question, I'm sorry, I didn't hear it.
Oh, sorry. Okay, let me try again.
Yeah, sure.
For training machine learning models in scikit-learn or XGBoost, can we use Polars data frames as input data, or will we need to convert to Pandas/NumPy first?
Oh, this is such a good question. The answer is I don't know. Actually, I really should have, because that's part of what I do is do data science. I haven't tried it yet. I don't know, but obviously you can do the 2 pandas really easily. If you have your data frame all set up, you can always do 2 pandas. I don't know. I'm sorry, that's a really good question. No.
Okay, that's okay. And also for anybody watching, just to let you know, because Polars is so popular, we have another event as well in Polars, and it is going to be about 6 weeks from today on November 19th. It is called Understanding Polars Expressions When You're Used to Pandas. And I think that will answer a lot of questions that people have here. As it's structured that way. So we don't have the event posted on Meetup yet, but save the date on your calendar, and we can ask these questions then as well. Okay, so the next question is: have you converted to using Polars at all times now, or are there still situations where you reach for Pandas?
I honestly probably still use pandas more. so I'm a new convert to Polars. Yeah, I'd say I am starting to do more Polars, especially with the large data sets, right? It's so much faster. However, I have used pandas, I don't even know, 10 years now, maybe more. So it's like really ingrained, right? It's really ingrained in me. So I am still using pandas for small scale stuff because if I've got couple thousand rows, there's no reason for me to switch over to Polars yet. But as I am starting to work with larger and larger files, yeah, I'm thinking about Polars quite a bit more. And especially if nothing else, then trying to do some initial filtering with Polars so that I'm only pulling in what I actually need to into my memory, and then maybe converting it to pandas or something like that. But the initial filtering, the initial weeding out of rows or weeding out of columns, or if I just don't need a whole bunch of the file, I can do that with Polars, and then if I want to, I can convert to pandas or so on. So yeah, I'm still relying on pandas, certainly for the smaller scale analyses.
Another question is: when you make a copy of a data frame, is it still a shallow copy?
Ooh, that's another good question. I don't know that one either. That's a really good question too.
Okay, so what we'll do is we'll make a list of a few of these, and then we'll, see in 6 weeks. Next question is: hi, Dr. Kim, nice presentation. Can you list, and you might have done this, so let me know if you've already gone over it. Can you list some cons of Polars compared to Pandas?
Yeah. I think the biggest con, I think, for me is just that Pandas has been around for so much longer, and I'm already really, really used to Pandas. So the biggest con for me is, yeah, just trying to learn new syntax and trying to get used to that. I think that there are probably still a few more things that you can do with Pandas, with the Pandas code base. Again, Polars is pretty new, about 4 years old now. So there are still some methods and functions and things like that in Pandas that I know about that I don't necessarily know about in Polars. And some of them I don't think actually even exist yet in Polars. That's a yet because it's still an active code base that people are contributing to, all the time. So yeah, we're getting more and more stuff in the Polars package. But there's still, I think, some things in Pandas that you can do that you can't necessarily do in Polars. So that's maybe one con. Yeah, that's probably the biggest one. Yeah.
And there's another question. I'm a data scientist student in my sophomore year. Would you suggest someone who hasn't learned Pandas to learn polars first?
That's a good question too. Yeah, I mean, sure. Like, yeah, I don't think there's any harm in the polars, like just going for polars instead of pandas. Yeah, the only thing would be, yeah, if there are things that you can probably do pretty much all your analysis in polars. So yeah, might as well start with polars then, because it's kind of the up and coming anyway. Yeah, I think that's a good idea.
Great. Those are all the questions. There were lots of questions, very good questions. Thank you so much, Kim, for presenting to the Data Umbrella community. And the recording should be up within 24 hours. If you have any more questions, you can also ask on the YouTube video under comments section. And yeah, thank you so much for presenting, Kim.
Thank you.